Hey everyone, in this problem we have a leg. This is a pretty crudely drawn diagram, but bear with it. We have a leg being held up by this sling here, which is attached to some pulleys connecting it to a small mass. And we're given some information about the distance between where this leg is being held up and the hip joint of the body and its center of gravity. And we want to find what mass is needed for the leg to be held up. So what we know is that we want the leg to be in place. So we can assume that it's in static equilibrium. Now because the body is being held in place where the hip joint is, we're going to want to deal with torques rather than forces. So first I'm going to draw a free body diagram showing the forces much more clearly. So I'm going to draw kind of a rectangular shape here, showing off where the forces and where the torques are. I'll say that this right here on the left is where the hip joint is. That's going to be our axis of rotation. And there are two different forces that are going to be acting on the leg. First, originating at the center, is the weight of the leg. It's going to be pointed downwards like this. And I'm going to call it mg. I'm going to use a capital M to refer to the whole mass of the leg. Now secondly, acting upwards is the force from the tension of the sling that is pulling on it, which originates from this mass here. So I'm going to call this force, this tension force, I'm going to call it lowercase mg, because that tension is just going to be the same as the weight of that small mass. Now with torques, we need to know the distances from the axis of rotation. We need to know the lever arms, but we're given that actually because the problem gives us the distance between both the CG and the sling from the hip joint. So let's call this distance right here, which is given, the distance from the hip joint to the center of gravity. I'll call that x1. And the distance from the hip joint to the cord, the sling, I'll call that x2. Let me make that more clear. x2. Now, as we mentioned earlier, since the leg is not moving, it's going to be in equilibrium, which means that the net of all the torques is going to be 0. So let's go through each of the two torques. I'm going to use a standard coordinate system where counterclockwise is positive, which means that this mg right here, this force acting upwards, is going to cause the leg to tend to move in a counterclockwise direction. So I'm going to say that that force is positive. So the torque is mg times that lever arm, which is x2. And then opposing that would be the force acting in the clockwise direction, which is going to be this mg, because it's downwards with respect to the lever arm. So it's going to be minus, and then I'm going to write that as big M G x1. And as we mentioned earlier, this is going to be equal to 0. So all we have to do now is algebraically rewrite this equation to solve it for small m. So first I'm going to bring this term over by adding it to both sides of the equation. So we get big M G x1 equals small m g x2. Now conveniently, these g's can cancel out, so we're just left with mx1 equals small m x2. And lastly, we want to solve for small m, so I'm just going to divide both sides of the equation by x2. So what we are left off with is an equation for small m that's equal to big M times x1 divided by x2. And this is the equation that we'll want to use. So all we got to do is plug in the values we were given by the problem. So big M, the mass of the leg, is equal to 15 kilograms. And then x1 and x2, we just plug in for x1, the distance to the center of gravity. And then for x2, we plug in the distance to the sling, which is 78 centimeters. Now something that's pretty nice about this problem, if you want to take a little shortcut, is that we don't actually need to convert from centimeters to meters because those units are going to cancel out fully anyways. and we're left with an answer in kilograms. So if we put that into our calculator, then we end up with a mass of about 6.73 kilograms. So this is the mass that is required for this small object here to hold the leg up. And that's it for this problem. I hope this video helped you out. If it did, please consider subscribing, as it'll help me in making more videos like this. And if you have a question, leave a comment down below, and I'll do my best to help you out as best as I can. If you have a request for a future video, or you just like to hang out, my Twitch page and my Discord server are both linked below. So that's all for now. I hope you all have a lovely day. Bye-bye.